Hey guys, today is Monday. I won't be there again today. I have a doctor's appointment. Um, I was gonna come back on Friday, but then there was no school, and then I have a doctor's appointment today, and then tomorrow there's no school either. It's gonna be an e-learning day. Okay, your e-learning assignment is going to be to look on Skyward, and you need to write, and I'm very specific this time, your grade percentage. Okay, along with your letter grade. And those grades will be updated tonight. And so I definitely want you to be able to check that. I will tell you that if I come back and you have a bunch of missing assignments, I'm taking phones, iPads, and you're sitting in the front row. So you need to work hard today to get everything caught up and in and done. So check your Skyward and do your um, e-learning. I'm going to try to post it on there before. So if you have time today and you want to knock it out, you're more than welcome to. Okay, today we're going to do assignment 13. I'm sorry, I'm trying to be quiet. My kid's sleeping. Technically it's Sunday night, but and it's mid-segments of a triangle, day 1. Okay. So it says in each triangle, M, N, and P are the midpoints of the sides. Okay, and we've talked about midpoints before. Midpoints are the exact middle point of something. And so if we were looking at a line segment, any line, there is exactly, and I say exactly, but there's only one middle point in between these two ends. Okay, so if you drew 3 points on a line, we could say that this is exactly the center, and that means, that means that this is the midpoint. Okay, so it says in each triangle, M, N, and P are the midpoints of the sides. Okay, and what they mean by that is we have this side right here, W, U. P is exactly the center between W, U. Okay, and if you looked at this side from W to V, N is exactly the center of that. And I can zoom this in a little bit so you can see better. And then on the flip side of that too, if you looked at VU or UV, M is exactly the center of that line segment. Okay. It wants you to name a segment parallel to one given. Okay, and some of the vocab is really important because they want to know what's parallel. Okay, and so let's just quickly talk about parallel. Well, parallel lines mean that there are two lines, okay, that are never going to intersect. So if we look at these two lines, or like railroad tracks, or two streets, or on a highway, they never intersect. No matter how far that these lines keep going out and out and out, okay, they're never going to run into each other. Okay, and so that means parallel. I shouldn't do that big because I'm not trying to understand. Okay, so if we look at the picture, and so this little dash, that means parallel. Okay, and so it wants to know line segment, that's what the bar above it means, MN is parallel to what other line segment? Okay, so let's find MN. Okay, well right here is MN. What is going to be parallel to that? And I will tell you on all these, you either look straight down from that line or straight up. Okay, because it has to be parallel. And so our answer is going to be line segment UV. Okay, line segment UV. And we're going to talk, but this is double the length of this one. Okay, so, and the one way to think about this, if this is 1, then this is 2. Okay, and so they want a line segment that's parallel. And so you're going to put WU. That's the line segment that's parallel. And if you were to do UW, that's perfectly fine too. Okay? And so that's all we're doing on these. So let's look at the next one. Line segment NP, here's NP, is parallel to what? Okay, well I want something double in that size. Okay, line segment NP is parallel to what? It's going to be YX. So you're going to put YX, and you need to put the bar on top of it. Okay, it's parallel to this one. And we can't use V or W because W is just a point and we need a line segment. And you cannot use YM, this one. I'll put my turn marker back on. You can't use YM because it's a line segment, it needs to hold that entire line segment. And if you were to draw a little magic line going down, that's not going through that full line segment. Okay, it's just going through this part. It doesn't cover this full line segment. And so we want something to cover that full line segment. And so that one wouldn't work, okay? So you have to use the full one. Okay, let's look at 5. MP. Okay, MP. What is parallel to MP? Okay, and as I said, you either look, they got to be the same sort of direction, okay? And so it's going to be VW. VW. Okay, and so your lines are either always going to go like this or like this, okay, but they should be parallel, one being smaller than the other. Okay, so I got JI, here's JI, okay, and so we know that since it's faced this way, I should have another line segment that's smaller, but it's also faced this way, or on this side, okay, and so we always look to the left and right of that. So, and in this case, it's going to be MP, MP, line segment MP. Okay, look at 9. Take a second, find NP. Find NP. Take a second and find NP. Okay, and so now I want you to find what is parallel to NP. Okay, and if you said BC or CB, you're totally right. So it's going to be BC, or you could write CB. Those we've learned throughout geometry that those are the same. Okay. Okay, look at 11. XY. Take a second and you find XY and find me one that's parallel to that. Okay, well here's XY. Okay, and we always look either up or down. Well, there's nothing down, so it's got to be up. So what's either double the size, okay, so if our line segment's this, it needs to be double the size or smaller than our original line segment. And that one doesn't really look that much smaller. You could say or smaller. Okay, and this one, it's going to be MN. Line segment MN. Okay, look at 13. DF. Take a second, find DF, and find what's parallel to DF. Okay, well here's DF. What's going to be parallel to DF? It's going to be MN. Okay, and I'll turn it on for part 2.